In the final section of this chapter, we're going to be doing a full implementation of the stack ADT. Now, if you want to, you can go and look at the textbook, and the textbook already has the code kind of already done and already available for you to look at. While there's a couple of methods that are left for implementation. But what we're actually going to be doing here is kind of live coding. So over here, I'm not going to have any of the files from the book. I'm just going to code the entire thing effectively from memory. So there may be some minor differences, but the point is I want to go through everything step by step, right? Kind of in a development process. So over here, I just have the interface that we talked about earlier. So this is stack ADT. So this is the list of methods I need to implement and then kind of descriptions about how they should behave. So I need to build a class that can implement this thing. So let's go ahead and create a couple new classes. First of all, I'm going to create something called driver, something that I can have a main method in just for testing purposes. And then I'm going to make a second class. I'm going to call this ArrayStack. So I'm going to use that name to show that it's a stack that's implemented in terms of an array. Over here, you'll notice there's two other boxes here, right, representing there's two other things in my BlueJ project. So the first thing I have here is stack ADT, right, which is a file from last time. And then I'm also having over here empty collection exception. So this is another thing the book provides. This isn't a big deal. What this file does is it defines a brand new exception that can be thrown when a collection is empty. This thing is pretty simple. So rather than go through the implementation process, I'm just going to assume it already exists and we're free to use it in our ArrayStack implementation. So let's open these files. So I have ArrayStack, and then I also have the driver. Let's clean these up really quick. So let's go over here. For driver, I'm gonna leave it empty for now. We'll come back to it and add a main later. For now, it's just empty out the stuff we definitely don't need. And we'll do the same thing over here in ArrayStack. So let me just delete out all of this code here. And then we're good to start coding stuff. So my goal here is to implement the stack ADT. And then once I've implemented it, I want to do a little bit of testing. So my interface file that I had earlier is the list of everything I need to do, right? All the methods I need to implement. So what I'm going to start by doing is copying all of these things over here to my new class, right? To my ArrayStack class. I'll copy these over here, right? Because I want to have kind of a list, right, of everything that I want to do. So I can just copy that directly from the interface, right? That's what the interface file gave us. So over here we have our now copy and pasted in our code. Right now though, this actually won't compile anymore because these methods here, right, aren't implemented. For an interface, it's fine to have methods that aren't implemented because that's what interfaces are designed for. But once you start telling Java that you're building up a class, then Java will complain if those things aren't implemented. So right now, things won't quite work. What I'm going to do here is do the kind of the bare minimum to make this thing compile. And then I'll walk through and actually implement each of these one by one. So in order to get this to compile, I'm going to need to give these bodies, right? So I'm going to put in my curlies that just say, oh, you have a method. Same thing over here. Since this pop method actually has a return type, right? Since it's returning t, it's actually getting an element. It will also actually need to type in a return here. So I'm just going to put in a return null to represent that I'm not returning anything. Let's see. Well, over here I have peak. Peak, I can do the same thing. I can put in my return null just as a placeholder again. And I'll kind of continue it over here. For is empty, well, let's just do return true. Really, there should be some logic there, but just to make it compile, I'm going to put in that statement there. For size, we'll do a return -1. Close that up. To string, kind of do the same thing. We'll just do return blank string, right? And I'll close that up as well. At this point, I have basic method bodies for everything inside of this interface, right? Inside of this object, right? This is a list of things I need to implement that I got from the interface, and I've just done the bare minimum to make sure they compile. And if I compile this, it should work. It looks like we got one error here. So the error here is complaining that it can't find symbol class T. So what it's complaining about is this T thing here. Well, if you think back to the interface had T available because it was a generic, because we knew that anybody could take stack ADT and choose what type of data they wanted to store into it. And the way we indicated that in Java is by having these arrows, right, these angular things, and the letter T, right? So that represented, oh, I have a generic type that this thing's supposed to be based on, right? So it can be string, it can be integer, it can be any sort of object or class type, right? I can put anything in there. But ahead of time, I don't know what it is. Well, the issue over here that I'm getting when I'm trying to compile ArrayStack is that I haven't defined that T is okay, right? I haven't said that ArrayStack is a class that uses generics. And so right now Java's just saying, oh, hey, you're using T, but I don't even know what T is. So I'm going to have to go up here to my main definition for this class and add in code to define that I want to have a generic type available. So in this case, I'll add in my arrows around the letter T. And that'll tell Java that I want to have this generic type T being used throughout this class. So let's try compiling this, and now we get no syntax errors. So everything looks good there. Although everything compiles, I do need kind of one finishing touch over here for my public class line. And what I need is I need to implement the actual interface that we copied this stuff from. So I'm going to type over here implements. It should have an S in there. Stack ADT type T. So what this whole line now is saying is that this file, right, contains a public class called ArrayStack that uses the generic type T. And that class, ArrayStack, is actually implementing the stack ADT interface. That just says that ArrayStack is providing all the functionality that stack ADT lists out. Over here, you'll notice that we have another generic definition. So this is just saying that, stack is in terms of some generic type. And that generic type, right, that T there has to be the same as the generic type that my ArrayStack is using, right? So my ArrayStack is using T to provide that T-typed stack ADT implementation, right? These have to match is the point. These have to match, right? I have an ArrayStack on this generic type that implements this interface with the same generic type. I don't want to have, ArrayStack be for integers and then stack ADT be for strings. Those have to be the same. So I need to have T here and T here to represent that this is implementing this over the same type. Let's go ahead and compile, just to make sure everything still works. In a lot of these videos, you probably see me clicking compile a bit, and I haven't really explained it. Simply put, if there's bugs, I want to know them as soon as I can, right? I want to have things compiling as soon as I can so that I can kind of address any typos that I've made rather than, write a ton of code and then have to spend all this time trying to figure out where exactly I've gone wrong.